In 2024, a maternal health agent in Kisumu asked a woman, "When was your last prenatal visit?" She replied, "2 weeks ago, you were there." The agent said, "I don't remember that."
Just think about that for a second. Imagine putting your trust in a system that's supposed to guide you through one of the most important times in your life, only for it to give you a digital blank stare. This is so much more than a software bug. It's a broken promise. It's a failure, not just of the technology, but of that fundamental trust between a person and the tool that's meant to help them. The one system that should know her best treats her like a complete stranger, every single time. This isn't just some small inconvenience. It's a moment that shatters confidence, and it can have very real consequences for a person's health and well-being.
So why? Why did this happen? Well, the answer sounds pretty simple on the surface, but it really opens up this huge gap in how we think about building AI for everyone, not just for a few people in wealthy countries. There are really two likely culprits here. First, it's possible the agent just had no memory at all. It was built to be stateless, basically wiping the slate clean after every single conversation. The second possibility, well, in some ways, it's even worse. The agent tried to remember everything, got bloated with all this data it didn't really need, and then just crashed her $50 phone. The kind of device that billions of people actually use every day, not the $1,000 flagships we test on in our labs. Either way, the result is the same: a total failure of design and, honestly, of empathy.
So today we are tackling what seems like a basic feature, but is actually one of the most ethically complex and technically tricky parts of building a real AI agent. This is phase 5 of our journey: add agent memory. And listen, this isn't about just picking the right database or figuring out how to store more stuff. This is about a completely different philosophy. It's about remembering with responsibility, with frugality, and with a deep, unwavering care for the human being on the other side of that screen. I'm Marcel Masaga, AI engineer, 5X founder, and fractional CTO. For over 20 years, I've been building real-world AI systems. Not in theory, not in academic papers, but in the trenches where the code meets the real world. This is about code that runs, systems that scale, and impact that is measured in human lives, not just in server logs. My work has taken me from building AI-powered diagnostic tools in East African clinics, where connectivity is a luxury and a miscalculation can have immediate consequences, to bootstrapping award-winning startups from the ground up. I've had the privilege of mentoring the next generation of founders, advising investors on where technology is truly headed, and serving on 5 global AI ethics bodies, grappling with these exact questions at a policy level. In all of these roles, one central question has driven every single decision. How do we build AI that doesn't just work, but matters? That is the mission of this show, The Global AI Engineer. We cut through the hype to think deeper and build wiser. At SIHA AI, the organization I lead, we don't even consider adding memory until phase 5 of our 10-phase agent development process. And that's not an accident. It's a deliberate, disciplined choice. Because we believe, and our experience has proven, that memory without a clear purpose isn't a feature, it's negligence. So today, let's learn how to build it the right way. So why do I call memory the soul of an agent? What is it that really elevates a simple tool into a true partner? This distinction is absolutely critical, and it's one that the market, in its big rush to ship products, often just ignores. As engineers, as builders, we have to be laser-focused on this. Memory is the foundation of context. And you know what? Context is the foundation of trust. Without it, you don't have an agent, you have an amnesiac. Think about it like this. A chatbot lives completely in the moment. It has the attention span of a goldfish. Its entire world is just the last few things you said. But an agent, a real agent, lives in your history. Without memory, your AI is a stranger every single time. It asks the same basic questions over and over, repeats the same generic advice, and stays completely, frustratingly unaware of your journey. But with memory, everything changes. It becomes a partner. Instead of just asking, "Do you have a cough?" it can say, "Okay, when we talked 3 days ago, you said the cough was mild. Now you're saying it's been 5 days and it's getting worse. That's a big change. We should probably talk about getting tested for TB." Or in finance, instead of a blank slate, it can say, "I see you successfully repaid a $500 loan last month. Now you're asking for $1,000 to buy more inventory. Let's figure out how we can support that growth." You see? It moves from just a transaction to a real evolving relationship. But, and this is a huge but, this power, this ability to build relationships, it comes with a massive, sobering responsibility. Because memory is dangerous. A few years back in Lagos, a well-intentioned mental health agent was created to give people anonymous support.
And to create that feeling of continuity, it stored raw voice logs of users' sessions. It basically became a digital vault of people's most intimate, vulnerable moments, talking about depression, problems at home, their deepest fears. And then it was hacked.
10,000 private therapy sessions were leaked onto the dark web. The damage was just incalculable. Lives were ruined. The trust in that entire type of tool was shattered for a generation. That single horrible event taught us a lesson that we have to burn into our professional DNA. Memory isn't a feature you just list on a website. It's a covenant. It's a sacred promise between you, the builder, and the user. And in places all across Africa and the global south, where privacy isn't just a nice-to-have but a core part of community and personal safety, that covenant has to be honored with every single line of code we write.
So, if we accept that this is a covenant, how do we even start to build a system that honors it? We have to go from the philosophical why to the engineering how, and it all starts with a clear technical blueprint. Every single intelligent agent, I don't care what it does, needs two fundamental and very different types of memory. Getting this architecture right from the very beginning is the first and most important step to building a responsible system.
Okay, let's break this down. First, you have short-term memory. You can think of this as the agent's working consciousness. Its only job is to track what's happening right now in this conversation. It's stored in places like RAM or with LLMs inside the context window. The context window is really just the recent chunk of conversation that the model can see. So an example would be the list of symptoms a patient is describing in one session. The best practice here? Keep it lean. Don't clog up the context window with stuff from months ago. It's expensive, it slows things down, and it can actually confuse the AI. This is your session buffer. Then you have long-term memory. This is the agent's permanent record, its history book. Its job is to remember what's happened over time across many different conversations. This gets stored in a database. It could be a simple SQLite file on a phone or a fancy vector database in the cloud. We'll get to those in a second. Examples here are a patient's whole medical history or a user's preferences. And the best practice for long-term memory is even more important. Store only what is absolutely essential for the agent to do its job. Period.
Let's make this really concrete with a case study. Our tuberculosis screener that's used by health workers in Malawi. For its short-term memory, during a single chat, it's tracking the immediate answers. How long has the cough been? Is there a fever? Any recent weight loss? That info basically lives and dies with that one session. But its long-term memory is what makes it so powerful. It securely stores the critical history, dates and results of past TB tests, the patient's HIV status, which is a huge risk factor for TB, and a log of their clinic visits. This long-term context lets the agent see patterns a person might miss. It can understand risk over time and give advice that's super personalized and clinically relevant. It's the difference between a generic checklist and a diagnosis that could save a life.
But here is the most important point, the ethical line that we absolutely must draw. Long-term memory has to be frugal. It has to be minimalist by design. In that Malawi project, we do not store raw voice recordings, we don't keep the full chat logs, we specifically engineered the system to pull out and store only anonymized, structured data, like symptom flags. It's a simple yes or no for a fever, not the person's whole story about how they're feeling. And we don't keep data forever. Our default policy is to get rid of sensitive health data after 30 days unless the user gives explicit consent to keep it. We have to burn this principle into our engineering culture. Remembering everything isn't intelligence, it's surveillance, and we are not in the business of surveillance.
This whole philosophy, this commitment to being frugal, to privacy, to user control, it's let us develop a totally different architecture for memory. It's a new paradigm, and it wasn't born in some air-conditioned data center in California. It was born in the field, responding to the real-world challenges and values of the communities we serve. I call it the African memory stock. Let's look at how this builds a system that's more resilient, more respectful, and at the end of the day, just more effective. So let's compare the two big models. The default Silicon Valley approach usually involves these huge cloud-based vector databases. Now, they're powerful for sure, but they are completely dependent on the internet. They put the user's data under company control, often in a totally different country, subject to foreign laws and surveillance. The Nairobi model, the one we've built out of both necessity and principle, is the exact opposite. It's on-device and encrypted. It's offline first, designed to work perfectly even without an internet connection. And most importantly, it's user-owned. The user holds the keys to their own data. It's a fundamental shift from a model of data extraction to a model of data empowerment.
So what does this frugal memory stack actually look like? Let's walk through the 4 layers. Step 1 is the storage layer. We use a simple, tough, battle-tested SQLite database that lives right on the user's phone. It's encrypted end-to-end. There is no cloud dependency for its main job. It can work offline for weeks, even months. Step 2 is data design. This is so important. We have a strict policy. Store structured facts, not raw logs. So we store symptom, cough, duration, 5 days, not a recording of the user talking about their cough. We systematically strip out and anonymize all personally identifiable information: names, IDs, locations. Step 3, the retention policy. We literally engineer the system to forget. Sensitive data gets automatically deleted after 30 days. The user is always in control. They can extend that or wipe their history with one tap. And finally, step 4 is the sync strategy. In a disconnected world, how do you get updates? We use Bluetooth. A health worker with a clinic tablet can securely sync updated guidelines or a patient's lab results right to their phone. No internet required. This is a complete, sovereign ecosystem.
And why does all of this matter so much? It comes down to this number, $50. In places like Turkana, in northern Kenya, a place with huge distances and almost no connectivity, this entire stack, this secure, private, offline-first, user-owned memory system runs perfectly on $50 phones. Phones that often don't even have a data plan. No constant connection to the cloud. No safety net. In an environment where the cloud is a luxury and privacy is a necessity, this isn't just a clever architecture. It's the only one that really works. It's the only one that respects the user's reality. Because sovereign AI doesn't just remember, it respects.
Okay, we've talked about the why and the how. We've looked at the technical blueprint and a real-world model for doing it. Now let's make this super practical for you, the engineer, the founder, the builder who's listening to this. It's time to go from theory to action. Don't just tack on memory as a feature. Engineer it ethically from day one as a core part of your agent's design.
Here is your 4-step action plan for Phase 5. Step 1. Define what to remember. Before you write a single line of code, ask the tough question. What specific information from the past is absolutely essential to serve this user better? For maternal health, it's the last visit date and risk factors. For a microfinance agent, it's loan history. The rule is simple. If it doesn't directly improve the user's outcome, do not store it. Step 2. Choose your memory architecture. Be deliberate. Building for a low resource area? An on-device SQLite model is your best friend. Building a cloud-native agent for users with good internet? Then yeah, a vector database with a RAG pipeline might be the right call. And RAG just means the AI grabs relevant facts from that database before it answers, which makes it way more accurate. Or maybe you need a hybrid model. The context decides the architecture. Step 3, implement Frugal memory hygiene. This has to be built in, not bolted on. Set up auto-deletion policies, encrypt everything. And, this is key, log every single time the agent pulls from long-term memory. This gives you an audit trail. Step 4, test with real users. Get out of the building, go to where your users are. In places like Kakamega, we sit with people and ask 2 really simple but powerful questions. Does this agent remember what actually matters to you? And does using this feel safe? If the answer to either of those is no, you're not done. It's back to the drawing board. To make this even more concrete, at SIHA AI, no memory system gets deployed until it passes our sovereign memory checklist. It's just 4 questions, but they are absolute deal breakers. 1. Is it minimal? Are we storing only the bare essentials and nothing more? 2. Is it secure? Is the data encrypted with strong, modern standards with keys the user actually controls? 3. Is it user-controlled? Can the user easily see, edit, and delete their own data, no problem? And finally, 4. Is it offline compatible? Can it do its main job without a constant internet connection? See, these aren't just tech questions, they're ethical questions, and we work from a core belief that memory without ethics isn't an asset, it's a liability waiting to explode.
And this brings us to the end, to the ethical imperative. That's really behind everything we've talked about today. This is bigger than choosing a database. This is about our role, our fundamental responsibility as people who create technology in a world with some very real power imbalances. This is about the future we are choosing to build with every single line of code. Let's be real. We are living in an age of data colonialism, an age where huge amounts of data are taken from communities, often in the global south, then processed and sold somewhere else, with very little benefit going back to the people who created it. In this world, how your agent remembers is just as important, if not more important, than what it remembers. Your choice of architecture is a political choice. In Africa, we know from experience that trust isn't something you can just extract. It's a relationship you have to earn, slowly and carefully. And that understanding forces us to build differently. It leads us straight to memory systems that are, by their very nature, frugal, sovereign, and temporary. So the bottom line is this. We're at a fork in the road. We have a choice between 2 futures for AI. In one future, AI hoards every little piece of our lives, creating this perfect digital copy of us for reasons we might never understand or control. It's a future of surveillance as a service. But there's another future. A future where AI is a respectful, focused partner. And the best AI doesn't hoard your life, it honors it. It remembers just enough to be helpful, and then it respectfully, gracefully forgets. So I want to leave you with a challenge. A challenge for every engineer, every product manager, every founder listening right now. As you get to this critical phase in building your agent, don't just add memory. Add responsibility, add foresight, add respect. Because an agent that remembers without care, without consent, without a deep respect for the user's sovereignty, that agent isn't smart, it's dangerous, and we have to be better than that.
If you found this valuable, please do 3 things. 1, hit the like button. It tells the algorithm this content matters and helps other builders find it. 2, subscribe and hit the notification bell, because next week I'm revealing Phase 6, use tools and external APIs. This is where your agent learns to interact with the real world, and it's an absolute game changer. And 3, check out my latest video, Stop Calling Yourself a Prompt Engineer. It's already changing how engineers and founders think about what it means to truly build in this field.
I'm Marcel Masaga. Thank you for being part of the Global AI Engineer. The work we are doing together matters, and doing it right matters even more. I appreciate you spending your valuable time here, thinking through these critical issues with me. Until next time, think deeper, build wiser, lead with courage.